Good morning, everyone. The school printers have decided this is a good morning not to print, and so we're going old school here. So all we're going to talk about is previously I had you simplify each side of an equation to then eventually come up with a solution through guess and check. Today we're going to talk about where we can expand upon our technique so no guess and check is involved. So we're going to look at a few cases. The first one is going to be about as simple as it gets, just so I can prove that this technique works. So let's say the equation I give you is 2x plus 19 equals 35. So remember, we've got our barrier. We can't simplify across it. And so really, I can't simplify these two things. They're not like terms, and there's nothing to simplify over here. So traditionally, we would say 2 times what plus 19 equals 35. Well, basically, I think the number plus 19 that gets me 35 is 16. And so for me, I'd say, oh, an 8 probably has to go in here because 2 times 8 is 16, plus 19 would be 35. Well, basically, there's a barrier. Like I said, we can't simplify. But as long as we do something to one side and do the exact same thing to the other, then basically our equation should stay equal. So in other words, let's say I don't want a 19 there anymore. If I take away 19, things would be unequal unless I also take away 19 from this side. So in other words, I would get this. So now I'm saying that whatever 2 times some number should be 16, which is exactly what we were thinking about right here. This 0 plus 0 doesn't change anything, so really I just have a 2x equals 16. All right, and so once again, you might think, oh, 2 times 8 is 16, so my answer must be 8. That's true. All I'm going to do is just say, remember, this is 2 times x, so the opposite of 2 times x would be to divide by 2. And once again, as long as I do that to both sides, I'm in good shape. And so 2 divided by 2 would be 1. 16 divided by 2 would be 8. Or more simply, just x equals 8. Cool. So those are my formal techniques. If I want to, basically I want to get x on one side and I want to get a number on the other side. So to do that, I took away 19. I got x on one side, a number on the other. But just to get x by itself, I had to do a division step. And here we can check 2 times 8. That would be 16 plus 19 equals 35. We're in good shape. All right. Let's take a look at a slightly more complicated example. All right. So once again, I'm going to draw on my barrier. So remember, this one's a little bit more complicated because whatever x is on this side, it's got to be exactly the same on the other side. And before, that meant a lot of guessing and checking. But here, we don't need to guess and check at all. So I can start with multiple steps here. It doesn't actually matter what you start adding first or subtracting first, as long as you're doing the same thing to both sides. So once again, I can't simplify that, and I can't simplify that. So now I'm going to try my solving technique. Well, I want all my x's on one side, so in this case, I think it might be easy to try and take away 5x from both sides. I could have easily decided to take away 8x from both sides, which would have been just as true, but I would have been dealing with some negative numbers. Not bad, but a little bit more prone to error. All right, so in this case, notice how I had 8x on this side, 5x, and so I tried taking away 5x's from both sides, and I got a 0x. Well, 0x means there's no x's, so really, I have a positive 21 left on this side, or just 21. And now I have 3x minus 6. Well, notice how I have a minus 6 rather than a plus 6 this time. So the same idea is going to apply, but instead of subtracting, which would get more negative, I'm going to add. And so now I'm going to see that 27 equals 3x, and negative 6 plus 6 is 0. Now notice how I have my x on one side and just a number on the other, but it's still a 3x, and I want it just to be x. And so my final step here is going to be divide by 3. 3 divided by 3 is going to be 1x. 27 divided by 3 is going to be 9, or more simply, x equals 9. So just remember, I write every single step to make things clear, but when I solve this myself, I don't usually write this step, and I don't usually write this step. So just keep that in mind. All right, so now I think this is true. Let's go ahead and let's throw a 9. Let's see if it actually checks out. 5 times 9 would be 45 plus 21. 8 times 9 would be 72 minus 6. Remember, I can't simplify across, so I'm going to say 45 plus 21 is going to be 66. 72 minus 6 is also 66. We get two things that are equal, so once again, we're good to go. So all we're doing is saying, as long as I do something to one side and stay true to my like terms, everything's going to end up working out. All right, I'm going to give you one last example. And this one's a little bit unique because I might actually have to use my simplification skills before I can do anything else. So here is what I mean. All right. So once again, I have two sides. But this one's complicated just because I've got to figure out what goes in for 3 different x's. I'm going to go off the page here a little bit, but we'll come back to that. So here, before I do anything, here's the big note. If you can simplify, do it. It's going to make your life a lot easier in the long run. So here on the left side of my equation, I see a 2 times x plus 5 in parentheses. So I'm going to do that. What's 2 times x? 2x. If it helps you remember, there's a 1 in front of x technically. 2 times 5. Cool. That's going to be plus 10. And on this side, I see my negative 4x minus 4x more. So really, I see a negative 8x minus 20. All right. Now I think this side's as simple as it's going to get because these aren't like terms. And this side's as simple as it's going to get because these aren't like terms. All right. So now I have a few options. I try to get my x term to be positive. So if you wanted, you could always subtract 2x from both sides. That wouldn't be wrong. It's just a little bit more difficult. Sorry for that announcement. All right, so instead, I'm going to say I have a negative 8x, and I don't want that anymore. So I'm just going to add 8x to make it 0, and I'm going to do the same thing over here. I'm going to add 8x, so that's going to get me 10x on this side, plus 10 still. Here, I've got negative 8x plus 8x. That's going to be 0x, and then I still have my minus 20. So remember, 0x means I have no x's anymore. So really, I have a minus 20 or a negative 20. So I'm just going to clean that up a little bit. All right, so now x is on the left side. There's no x's on the right side. I want to get x all by itself, or the x term. So this plus 10 is getting in the way of that. So I'm just going to take away the 10, which is going to give me 10x plus nothing equals negative 20 minus 10 more will be negative 30. Really, this isn't there anymore. So I'll write 10x equals negative 30. But remember, I want to know what 1x is, or just x. And so 10 times x, the opposite, is going to be to divide by 10. So that'll be 1x equals positive divided by, or sorry, a negative divided by a positive will be negative. And so my claim is that x is going to equal negative 3. All right. So once again, I'm writing every step. When you're doing this, you might skip certain steps. That's okay, as long as you're following all properties. So let's check it. Let's throw negative 3 into our boxes here. Parentheses first, so negative 3 plus 5 will be positive 2. So I'm going to have 2 times 2. If it helps, draw on your barrier. I have negative 4 times negative 3. That'll be 12. Minus 20. Negative 4 times negative 3 will be positive 12 again. All right, so this is going to be positive 4. 12 minus 20 is negative 8, plus 12 is also positive 4. So we're good to go. So that's my final answer right there. Cool. So give those a go. As always, if you have questions, reach out. And otherwise, I look forward to talking to you all soon.